Welcome back, everybody. I'm Mason from Signature Solar. We're joined today by James Showalter, the owner of Signature Solar, and today we're answering some questions about the Schneider Backup Control Switch, the BCS. So we'll go ahead and get into it. Our first question, James, this BCS, it fits a category called MIDs, right? Can you tell us a little bit about what MIDs are and how they're helping out customers, helping out solar users?
Yeah, so an MID I think stands for a microgrid interruption device. I think if you look at the evolution of the backup inverter, including the evolution's a great word when you're talking about the Schneider Connects, because it's probably one of the greatest examples of an inverter that's been in the field for longer than most of the owners of the existing hybrid companies, even before they even knew what MPPTs were. If I were to make a joke about that, like Schneider's been in it since 2001 and technically Trace before them. So you've got one of the oldest inverters there, and so that evolution started with a 60 amp internal transfer switch. 60 amps is great, but it's not a whole lot, and people are trying to interplay all the effects of really storage systems and backup systems with the ability to also have a 200 amp regular lifestyle when they're normally connected to the grid. It's just a matter of either consternation, it's code, or it's actual needs of people being willing to have less backup when they're backed up and use energy more frugally if they run a backup mode. And then also at the same time, run the full 200 amp lifestyle, 99 point some odd percent of their overall solar and storage experience. So the next thing people came up with is, let's just grow that relay to 200 amps inside of the inverter. Then the problems for that started piling up. Of course, we have the 200 amp 18K PV, right? And there's a lot of hidden cost in getting a professionally code compliant, permit ready system installed. You think that would be that's all you need. But the problem is you're going to need a 200 amp fuse disconnect. By the time you buy that, that's $600. Then you're going to need, frankly, a bypass 200 amp transfer switch. In a lot of jurisdictions, you show them the inverter and you tell them the relay is going to short across if there ever was an issue, input to output, and okay, that'll solve a problem. But for a lot of code inspectors, that's not going to fly. These are things that you have to ask. So you could be $1,200 into it on hardware, then you got to buy wire, conduit, and then of course whatever your time's worth. I tend to assume that actually hooking up a 200 amp inverter in a lot of grid areas where they're very stringent on code or the tightest interpretation possible, you're looking at another $2,000 on top of what you think that inverter costs. So those two key points are overcurrent protection and on the input side, and the interrupt switch as well to bypass. So what an MID does is it goes right to the source. As you can see with our display here, we've got that meter base. And this is really how I think you're going to see this installed in a home. This is outdoor rated. It goes right into your meter before you go into your house, kind of like a Generac switch. And we have a bypass switch right here. So if you needed to bypass to the grid in the future, you have that opportunity if there's ever a failure in the switch of hardware. And you have a 200 amp Schneider breaker. And of course, the entire approach here, you're talking about a Schneider Electric solution. They're hyper-focused on code. They're highly recognizable. You don't have to sell them. So this right here removes that $2,000 you spend if you were trying to retrofit a house with a battery storage system. And I think that's really the problem is, what's the most efficient way to have a stack of batteries affect your existing solar system? So the MID there is not a way that people are used to thinking about things. It works in parallel with that inverter. So it's basically two devices working together versus one big relay, which then needs a whole lot of protection.
I think it's huge how it goes a long way. Also, one of the main points that helps is take full advantage of your backup system, of what you have in reserve, and not to be clamped down on the amps and how many you can use with what you have in your backup. So that's a great point. Next question, to use the BCS, does it matter if it's an AC or DC coupled system? Or another way to look at that question is, what's the best system to integrate the BCS into?
Yeah, so I think there's a lot of different categories of problems people are facing in the market right now. In theory, absolutely, you could put in the classic Schneider DC coupled system with MPPTs, You technically would not need the power distribution panel they have if you invest in the BCS system, because of basically the Schneider XW is looking at that battery state of charge, and it's going to use the central meter inside of the BCS and drive your mentality there of self-consumption. So whenever you would normally be selling with a grid tie system, it would instead shave out that excess power you would be going to the grid with and dump it in the batteries. So a DC coupled system, if you're starting from scratch, would work great. There's a tremendous demand for people who have AC coupled systems. Either they have to start from scratch with AC coupled, or they already have a system. And right now, we're getting these questions all day long. My power company cut the excess compensation. I'm no longer getting paid well for it. What do I do now? How do I hook your batteries up to my house? With the BCS, it's really just, okay, we have this backup inverter. It'll charge with the excess power you're selling, and then it'll use that power to support the house at night.
Absolutely. Yeah. Our next question here, looking at what will a single inverter be able to back up? Right. Somebody just has one 6.8, XW Pro. What can it back up? And how is the power quality of that inverter different from other inverters?
Yeah. So I think that's a really strong suit for the Connect XW. They have, I think they're probably the humblest rating in the industry. They call this thing a 6.8, right? And technically, if you're a Bitcoin miner who only uses the same load for 24 hours, that's solid, then it's 6.8 to you. But the surge capacity, when you look at how a house actually works, and just my own experience doing off-grid installs for the last 8 years, the houses, surge for a while and then come back down. And so the capacity is incredible, in my opinion. There's two factors that are really good with that: that long-term load surge, and then the line balancing aspect. So if you remember with the Schneider, you're looking at 8.5 kilowatts, 8,500 for 30 minutes. And I think it's like 11,000 watts for 5 and 12,000 for 1. And then the cool thing is you can pull 100% of that power off of one leg or the other. So when you look at all the factors that people are looking at with these high-frequency transformerless inverters, like, for instance, our 18K, several others in the market, then, there are several factors that just really aren't designed for the average user, which the Schneider has been built right on from day one. And of course, it does that with a 20-watt idle current. Right. So there's a huge amount of overall operational savings, 50 watts an hour at least, compared to an alternative. The power quality, I think we did a video about a month or so ago, right?
Right, we had the two 6.8s running in parallel power, and we did the load test for those as well. Kind of hit some of those same points as far as the surge, looking at the 8,500 watt surge. We mentioned that on the single line. So, the BCS doesn't necessarily eliminate the need for more than one inverter if you want that much more power. But what it does do is allow that surge to happen on the one inverter and protect your system that you have in place. But
you're in the game if you buy a $3,600 inverter with the BCS. And that's kind of where, when you look at the cost of the BCS, it's significantly less than all the other switchgear you're going to buy with one of these 200 amp inverters. So when you look at how much you can get out of one package, I think that's always been what shocked me about this inverter. And it's, I think, 96% efficient, going to 48 volts, which is pretty good for a 48 volt inverter. But then there's a hidden efficiency with that idle wattage being so low that you're getting. But I think we did that light video, right, where we took the whole wall of LED lights and we tried it on multiple different inverters. And I think we're going to have to do an updated one with the 18K because it wasn't out at the time. Right. But it's still nothing is as good as the Schneider XW on power quality. It's the closest thing I've ever seen to the grid. And honestly, that's the kind of stuff that's what you get for being in the business for, frankly, 20 years. I think they acquired the company that started 20 years ago, and then like about 06, 07, they've been running it since then, but they kept the same team. I know that some of the staff on the XW team has been here since 01, 02. It's ridiculous.
Right, some of those engineers.
Yeah.
And it goes a long way to have that continuity within the staff, and to mention that test again that we looked at, a lot of the ones we've done, it's been one of the most seamless transitions that we've seen.
Yeah.
Moving on, how does the BCS protect my inverters when my load draw exceeds that 60 amp? Right,
Okay,
the
so you're
60
looking
limit
at a
that we're looking at.
completely, yeah, exactly. You're looking at a completely different switchgear architecture. So people who are familiar with these classic inverters, they kind of think about, we've got an AC input and an AC output. I wish you had a diagram right here. And so you're typically going to put the grid input on the AC input and then put the backup loads on the output. Maybe it's a separate panel, whatever. That's completely thrown out the window when you're doing this. The controller inside of the BCS makes the XW run on essentially just the AC input line. And then that lands on the main breaker panel that you have in your house. So you drop a 60 amp breaker on that breaker panel and you backfeed that breaker tied to the BCS. So if you were in a backup scenario, the inverter internally will reroute the backup output through the AC input port. It has the internal relays in its main control board. And then it will run through that AC input wire and backfeed your house, while at the same time the BCS is disconnected the grid. So that's those two contactors networked together and working together is the whole concept versus that double throw relay. So how it protects the inverter is really just that 60 amp breaker you're going to put on your main breaker panel in the house.
So that's achieved through that backfeeding, not necessarily switching to an AC source. So not switching back to the grid, not switching to a generator.
When the grid's connected, people are going to ask, what happens if, I've got the inverter set up to where I want to maximize my own self-consumption. So if I have a battery bank at night that's full, I don't want to buy from the grid. Well, what if I'm pulling more than 60 amps for my house? When my house starts pulling 70 amps at midnight? Well, the beauty of the BCS system is it mixes the two. It's not like a shift of a new input. Because of the Connect is a paralleling inverter with the grid tie export, it can mix the power source, so it knows not to trip the XW inverter, and whatever else is needed, it will pull in from the grid. So it'll truly be this, I don't even know that there's something going on, and then you'll be able to track that on your Insight monitoring app as to how much you had to pull from the grid, if any at all. A lot of homes really aren't going to go above 60 amps on their off-peak hours. It'd be incredibly rare. Maybe it's a 1% time, but you don't want to have the inconvenience of needing the power, Okay. If you wake up at midnight and you turn on the oven and you turn on the dryer, then you're not going to overload the inverter because of the controller inside of the BCS is smart enough to know how to add how much grid power you need to support it. But you're also still going to get the full utilization that the inverter can provide to support that.
Best of both worlds.
Yes.
So if, going on to our next question, this one's I thought was a pretty good question. This is, do we need to install an external meter for importing and exporting, export limiting? The BCS is, that's a big market for it with the watt node that's installed in the BCS to limit exporting. Whether people maybe won't trust that or people still just want to go with their gut and install an external meter. But that need is not there to install that external meter.
So that's what I'm kind of seeing with the meter that they've built inside of the BCS. It's a fully integrated solution with their Insight system. So you've got that built in, and that really, I think you're going to be going to your Insight hub for more than just, is my solar producing power? And you're going to be in a place, because of that meter is tied into the Insight functionality, you'll see your entire usage life for the house, and you'll know a lot more about your overall power usage and really the whole picture, right? I mean, even people who've been just watching a grid tie system, if you've had one for years, you know that it's not the whole picture because of the energy used behind the meter. Well, with the BCS owns the behind the meter equation. So keeping track of all that's going to be possible. Exactly, you won't need additional metering. And
Comes with the charge transformers.
And the one that's in there is fully integrated with the Insight. So you'll have all that data in one place.
Right. Okay. Moving on, kind of the end of that Insight. Should I use an Insight home or facility for communication with the BCS? And with that, what can I monitor and control with this system?
Well, see, I think this is one of that early release questions we're running into with this, and we're working on a few different approaches on adjusting this, because with our partnership with Schneider on the battery communications, we're heavy on the RS-45 port. Well, the biggest issue I think we're facing is that the watt node meter is using the RS-45 port.
Right.
So the CAN port's open, but now we're really just having that whole project start over again. So the other way to make it work is that Insight home facility you mentioned. That's what we have on this display right here. It's the one with the dog ears. It costs a little more, but it has the capacity to have two RS-45 ports. Obviously in the efforts of cost efficiency, the Insight Home would be great. A lot of these systems are just going to involve two devices, the watt node meter and the inverter. So there's no reason to have the computing power of the facility.
Right.
So we're targeting that, but for right now, it's the Insight facility. I think it affects the price by about a couple $100, and it still creates that whole massive competitive edge of I want to add backup to my existing solar. Like I say, the BCS you actually save money on compared to all your switchgear, and then you're looking at a $3,500 inverter with 10-year warranty. And some of these XWs have been operating in the field for 18 years.
And communication, is a ever evolving, technology, whether that's through firmware, whether that's through the remote monitoring. That's something, and kind of like you mentioned, whether it's what is the case today, it might not be the case, a month or 3 months from now, on how that communication is working. I think those are all great points. That does it for us today. This has been James and Mason from Signature Solar. Thanks for joining us. We'll see you next time.
See you guys.
All right, everybody, after we had our chat, our roundtable discussion with James and myself, we got to talking and we wanted to put to the test. We figured some of you would want to see how much one of these inverters, just one 6.8 Pro, could actually put out. How much backup do we have on one inverter?
And this is trying to emulate a whole house. I mean, you got your meter, your BCS, your inverter. There's no power on the meter. You can see the meter screen is blank.
Right.
So we got a 4-ton whole house air conditioner here we had on a cart, dryer, lights, TV, and we're connected to the Insight local. So I think we got 69% charge in the batteries that are in our battery bank right there. And we're putting out 130 watts because of the lights and the TV. So
with that dryer and that air conditioning unit, we're expecting around 80 amps, correct?
Yeah, I think we're going to surge significantly higher than existing run load. Than that 6.8. So I'm going to start the dryer. Hold on a second. Okay. And then you've got the breaker over there for the 4-ton unit. I think between that, we'll have some 120 volt stuff. The light's probably going to flicker when we kick the air conditioner on, but just for a second.
Market pressure.
And then we should probably just see if we can keep it running, okay?
Absolutely, let's do it.
Okay, so wait for this to cycle. 5,800 watts. Says 5.8 on the inverter. Perfect.
Right.
Let's kick the air conditioner on, see if we can start the air conditioner still.
All right, getting to it. Nice.
That's beautiful.
We've got a fan running, full motor, compressor.
I love doing that.
It's nice, getting nice and cool in here.
All right, go ahead and kill it.
Okay.
Yeah, we can't run this test one that long because it's only got so much Freon. We don't have the real controller, but we just kicked that on. So you could cycle your air conditioner because the air conditioner is only going to burn about 2.5 kilowatts. And so, yeah, if you add 2.5 kilowatts to the 5,700, what's that going to be? Around 8,000 to 500, roughly in that range, a little under that. Right. So, but in theory, that can only go on for 30 minutes, but the dryer's heating element's going to cycle off and on in 30 minutes. The air conditioner's going to cycle on and off. You could also
15-minute run time.
You could use an oven too, and inevitably, you're playing a guessing game as to which ones are tripping on and off. But very likely you won't have any trouble, even if you were cooking something on the oven. That heating element cycles, this heating element cycles, and this runs. Or if you're trying to be more conservative, I mean, you could still just say, all right, either run the dryer or the oven. But everything else, you have a whole house of lights is only about 800 watts.
Right, I mean, it's beneficial to mention also that we're using this in an off-grid application. All this being ran completely off battery power, right, off the EG4 batteries. Yeah. So it's pretty impressive with the output that we have from the 6.8 coming from that.
Right, and that's in a $3,600 inverter, just tied into our batteries. I mean, to be able to be in that price range, have this, and it's a solid investment in terms of longevity and everything else. So, one of the most exciting things about this whole idea is what one inverter can do for the average American home. You'll have air conditioning, you can have one major appliance running, and then of course you can have 1,500 watts of 120 volt stuff, a washing machine, lights, electronics, really real backup. And as long as you have enough battery capacity, which our equipment's very cost effective on doing that, you really, backup's a lot more reachable with something like this.
A lot less stress, a lot less worry in case you do have a grid outage or something cut out. You still be able to live your normal life.
Exactly.
Your normal appliances operating.
That's what people are looking for. So hopefully this explains that. Oh yeah, look, the heating element already cycled off. We're down to 393 watts. And that efficiency ratio is really high, 390 versus 378. I mean, it's incredibly high efficiency in terms of 48 volt DC to 240 volt AC. But heck, they've had 20 years to figure it out, so they're kind of ahead of the rest of us, you know.
Yeah, absolutely. Well, that's awesome. Thanks for watching this load test. It's been James and Mason from Signature Solar. We'll see you next time.